Jakarta mail abstract class layer in Jakarta mail. Now we are focusing on Jakarta mail abstract class layer. The abstract layer declares classes, interfaces, and abstract methods intended to support mail handling functions that all mail systems support. API elements comprising the abstract layer are intended to be subclassed as and extended as necessary in order to support standard data types and to interface with message access and message transport protocols as necessary. As here you can see the structure and content of a multi-part message. The multi-part class implements multi-part messages. A multi-part message is a message object where the content type specifier has been set to multi-part. The multi-part class is a container class that contains object of type body part. A body part object is an instantiation of the part interface. It contains either a new multi-part contain object or a data handler object. This figure illustrates the structure and the content of a multi-part message. Here you can see a message. Here message the header attributes and content body are inside the message. Header attributes normal message includes a content type attribute set to multi-part. Content body normal message includes a content body type multi-part. Here the body type is connected to multi-part object. Body part object and another body part objects are here are inside the multi-part object. Here header attributes and content body are inside body part object. Header attributes defined by the part interface only. Attributes includes a second content type attribute. Content body, the content body itself can either a data handler object containing data or another multi-part object. This is another body part object. The multi-part message can hold more than one body part object. A multi-part message is a simple message object where the content type is set to multi-part and the content body carries a reference to the multi-part object. Multi-part object is a container of a body part objects where each body part can contain either a data handler or a multi-part object. Here you can see a typical nested multi-part message. Note that the multi-part objects can be nested to any reasonable depth within the multi-part message in order to build an appropriate structure for data carried in the data handler objects. Therefore, it is important to check the content type header for each body part element stored within the multi-part container. The figure here illustrates a typical nested multipart message. Here you can see the carries addresses for the entire tree and content body references multipart container inside message object. The content body references a multipart container is connected to body part object that carries data handler object holding data, and a body part object that carries out data handler object holding data, and body part object that holds data handler object holding multipart container object, and other body parts objects are inside multipart container object. Here the body part object that hold the data handler object holding multipart container object is connected to new body part containing data handler object here. The new body part containing data handler object and body part and other body parts are inside in other optional multipart objects. Here you can see the structure of a multipart message, and shows calls from the associated message and multipart objects for typical call sequence returning a body part containing text plain content. Typically the client calls the get content type method to get the content type of the message. If the get content type returns a MIME type whose primary type is multipart, then client calls the get content to get the multipart container object. The multipart object supports several methods that get, create and remove the individual body parts objects. Public int get count, public body get body part, body part index int index, public void add body part, public void remove body part, public void remove body part int index. The multipart class implements the Jakarta.activation.data source interface. It can act as a data source object for Jakarta.activation.data handler and Jakarta.activation.data handler data content handler objects. This allows message aware content handlers to handle multipart data sources more efficiently, since the data has already been passed into individual parts. This diagram illustrates the structure of a multipart message and shows calls from associated message and multipart objects for a typical call sequence returning a body part containing text plain context. In this figure, the content type attribute of message object indicates that it holds multipart content. Use the get content method to obtain multipart object. Here the message is connected to a multipart mix via get content type here, and here the message contains multiparts, and message is connected to multipart via get content method, and multipart contains body part. Multipart is 0 to n-1 here. Multipart is connected to body part via get body part index, get body part index here 0 to n-1. Here body part is connected to text plain via get content type, and here body part contains text. Body part is connected to text via get content method. Here you can see the code sample. This code sample shows the retrieval of a multi-part object. Now we are considering expunge process. Deleting messages from a folder is a two-phase operation. Setting the deleted flag on messages marks them as deleted, but it does not remove them from the folder. The deleted messages remove only when the client invokes expunge method on that folder object. The folder object then notifies the listeners by firing an appropriate message event. The message event object contains the expunge message objects. Note that the expunge method also returns the expunge message object. The folder object also renumbers the message falling after expunge messages in the message list. Thus, when the underscore expunge method returns, the sequence number of those message objects will change. Note, however, that expunge messages still remain their original sequence numbers. Since expunging of a folder can remove some messages from the folder and renumber others, it is important that the client synchronize itself with the expunge folder as early as possible. This section describes a set of this section describes a set of recommendations for client wanting to expunge a folder. Expunge the folder, close it, then reopen and refresh messages from the folder. This ensures that the client was notified of the updated folder state. In fact, client can just issue a close method with the expunge parameter set to true to force an expunge of the folder during the close operation, thus even avoiding explicit call to expunge. The previous solution might prove to be too simple or drastic in some circumstances. Now we describe the scenario of a more complex client expunging a single access folder. For example, a folder that allows only one read-write connection at a time. The recommended step for such a client after it issues a expunge command on the folder are: update its message count either by decrementing it by the number of expunge messages or by invoking the get message count method on the folder. If the client uses sequence numbers to reference messages, it must account for the renumbering of the message object sequence to the expunged messages. Thus, if a folder has 5 messages, as shown here, sequence numbers are within the parentheses. And if the client is notified that messages A and C are removed, it should account for the renumbering of the remaining messages as shown in this second figure. The next point, the client should prune expunge messages from its internal storage as early as possible. The next point, the expunge process becomes complex when dealing with a shared folder that can be edited. Consider the case where two clients operate in the same folder. Each client possesses its own folder object, but each folder object actually represents the same physical folder. If one client expunges the shared folder, any deleted messages are physically removed from the folder. The primary client can probably deal with this appropriately, since it initiated this process and is ready to handle the consequences. However, secondary client are not guaranteed to be in the state where it can handle unexpected message remove event, especially if the client is heavily multi-threaded, or if it uses sequence numbers. To allow client to handle such situations gracefully, Jakarta Mail API applies the following restrictions to folder implementation. A folder can remove and renumber its messages only when it's explicitly expunged using expunge method. When the folder is implicitly expunged, it marks any expunged messages as expunged, but still maintain access to those messages message objects. This means that the following state is maintained when the folder is implicitly expunged. Get message returns expunge message object together with valid messages message object. However, expunge message can throw the message expunge exception if direct access is attempted. Messages in the folder should not be renumbered. In the implicit expunge operation cannot change the total folder message count. The folder can modify listeners of implicit expunges by generating appropriate message event. However, the removed field in the event must be set to false to indicate that the message is still in the folder. When this folder is explicitly expunged, then the folder must remove all expunged messages, renumber its internal message cache, and generate message event for all expunged messages, with each removed flag set to true. The recommended set of actions for a client under above situation is as follows. Multi-threaded client can expect to handle shared folders are advised not to use sequence numbers. If the client receives a message event indicating message removal, it should check the removed flag. If the flag is false, then indicate that the another client has removed the message from this folder. This client might want to issue an expunge request on the folder object to synchronize it with the physical folder, but not caveat in the previous descriptions above using shared folder. Alternatively, this client might want to close the folder object without expunging and reopen it to synchronize with the physical folder, but note that all message objects would need to be refreshed in this case. The client may also mark the expunged messages in order to notify the end user. Next point, the removed flag was set to true. The client would follow earlier recommendations on dealing with the explicit expungers. Example, we can consider the package Jakarta.mail. The Jakarta Mail API provides classes that model a mail system. The Jakarta.mail package defines classes that are common to all mail systems. The Jakarta.mail.internet package defines classes that are specific to mail systems based on internet standards such as MIME, SMTP, POP3, and IMAP. The Jakarta Mail API includes Jakarta.mail package and subpackages. This package is in the module Jakarta.mail. As an example 2, we can consider these code segments. This is to send a plain text message. The class session, the session class represent a mail session and is not subclassed. It collects together properties and defaults used by the mail APIs. A single default session can be shared by multiple applications on the desktop. Unshared sessions can also be created. The class session is in Jakarta.mail package. Here in green color you can see the main code segments related to Jakarta mail abstract class layer. In example 3 we can consider this in the environment with the WebSphere application server. This is to enable the Jakarta Mail 2.0 feature at this element declaration into your server.xml file inside feature manager element. Actually the environment is here WebSphere application server Liberty. As example 4 we can consider this one. This is in Open Liberty. This is to send an email and to receive email from application. You can call the Jakarta Mail libraries in any application that runs on the server to send and receive emails. Create a jakarta.mail.session object by adding and configuring mail session. Mail session element here to enable the this configuration. In addition to enabling the Jakarta mail feature, you must also enable the Java naming and directory interface JNDI feature in your server.xml file. This example mail session is configured so that it can be used for both a simple mail transfer protocol SMTP and internet message access protocol IMAP. After you configure the mail session element, the mail session is created and injected by using JNDI. JNDI. the name of the WAR file is example mail. The class name is SMTP sender, and the name of the jakarta.mail.session object is Gmail SMTP session. If you use the standard JNDI context, Java colon comp/env/mails/gmail SMTP session, specify the JNDI name attribute as JNDI name equal mail/gmail SMTP session. As an exception example, we can consider messaging exception. The class messaging exception here. The base class for all exceptions thrown by the messaging classes. This is in the package javax.mail. Now we are considering multipart, the multipart class in message class. This code sample below shows the retrieval of a multipart object. The class message in package jakarta.mail in module jakarta.mail. This class models an email message. This is an abstract class. Subclasses provide actual implementations. The class multipart in package jakarta.mail in module jakarta.mail. Multipart is a container that holds multiple body parts. Multipart provide methods to retrieve and set its subparts. And this code sample shows the retrieval of a multipart object. Now we are considering example scenarios in the provider registry in the mail session. The client application invokes default protocols. The class session in package jakarta.mail in module jakarta.mail. The session class represents a mail session and is not subclassed. It collects together properties and defaults used by the mail API. A single default session can be shared by multiple applications on the desktop. Unshared sessions application on the desktop. Unshared sessions can be on the desktop. A single default session can be shared by multiple applications on the desktop. Unshared sessions can also be created. The mail session object manages the configuration options for and the user authentication information used to interact with messaging systems. The Jakarta Mail API supports simultaneous multiple sessions. Each session can access multiple messages, message stores, and transports. Any desktop application that needs to access current primary message store can share the default session. Typically, the mail-enabled application establishes the default session, which initializes the authentication information necessary to access the user inbox folder. Other desktop applications then use the default session when sending and accessing mail on behalf of the user. When sharing the session object, all applications share authentication information, properties, and the rest of the state of the object. For example, to create the session using static factory method, you can use get instance, or to create the default shared session, or to access default shared session, you can use method session.get default instance. The properties object that initiate the session contains the default values and other configuration information. It is expected that client using the API set the values for the listed properties, especially mail.host, mail.user, and mail.from, since the defaults are unlikely to work all cases. Some messaging system implementations can use additional properties. Typically, the properties object contains user-defined customization in addition to system-wide defaults. Mail-enabled application logic determines the appropriate set of properties. Lacking a specific requirement, the application can use a system properties object retrieved from the system.getProperties method. The authenticator object controls the security aspect of for the session object. The messaging system uses it as a callback mechanism to interact with the user when a password is required to log in to a messaging system. It indirectly controls the access to the default session, as described now. Client using Jakarta Mail can register password authentication objects with the session object for use later in the session or for use by other users in the same session. Because password authentication objects contain password, access to this information must carefully controlled. Application that creates session objects must restrict access to those objects appropriately. In addition, the session class shares some responsibility for controlling access to the default session object. First, call the get default instance method. Create a new session object and associate it with the authenticator object. Subsequent calls to the default get default instance method compare the authenticator object passed in with the authenticator object saved in the default session. Access to the default session is allowed if the both objects have been loaded by the same class loader. Typically, this is the case when both the default session creator and the program requesting default session access are in the same security domain. Also, if the both objects are null, the access is allowed. Using null to gain the access is discouraged because this allows access to the default session from any security domain. Mail-enabled client uses the session object to retrieve a store or transport object in order to read or send mail. Typically, the client retrieves the default store or transport object based on the properties loaded for that session. Client can override the session default and access a store or transport object implements a particular protocol by giving the name here. For example, IMAP. Implementation of store and transport object will will be there, and they can then make the session object available to other object contained within this store or transport object using application dependent logic. The application properties including Jakarta Mail required properties, mail.store protocol, mail.store.protocol, mail.transport.protocol, mail.host, mail.user. Get the store information, store implementation of the protocol defined in the mail.store.protocol. The implementation returned will be defined by the order of entries in Java mail.providers and Java mail.default.providers. Here now, as an example, we are considering the fetch profile method in the folder class in message, storage, and retrieval. The following code illustrate the use of fetch profile when fetching messages. From a folder. The class folder in package jakarta.mail in module jakarta.mail. Folder is an abstract class that represents the folder for mail messages. Subclasses implement protocol specific folders. The class fetch profile in package jakarta.mail in module jakarta.mail. Clients use a fetch profile to list the message attributes that it wishes to prefetch from the server for a range of messages. The message objects written by a folder object are expected to be lightweight objects. Invoking get methods on a message cause the corresponding data items to be loaded into object on demand. Certain store implementations support batch fetching of data items for range of messages. Client can use such optimizations, for example, when filling a header list window for range of messages. The fetch profile method allows the client to list the items. It will fetch in a batch for certain message range. The following code illustrates the use of fetch profile when fetching messages from a folder. The client fills its header list window with the subject from and xmailer headers for all messages in the folder. Now we are considering an example in operating on the content in Jakarta activation. Here we are considering weaving a message. This example shows how a weaver can be used to to display the content of a message that is usually text, plain text, HTML or multipart mixed. Here the class data handler in Jakarta.activation. The data handler class provides a consistent interface to data available in many different sources and formats. It manages simple stream to string conversions and related operations using data content handlers. It provides access to commands that can operate on the data. The commands are found using a command map. Consider a message viewer consider a message viewer bean that presents a user interface that displays the mail message. For example, this example shows how a viewer bean can be used to display the content of a message that is usually text, plain text, HTML or multipart mixed. Perform error checking to ensure that a valid component is created. A message passed in as a parameter. Now we are considering setting message attributes in message composition. Then it calls a set of methods which equate those addresses to appropriate message attributes. The class message in package jakarta.mail in module jakarta.mail. This class models an email message. This is an abstract class. Subclasses provide actual implementation. The message class provides a set of methods that specify standard attributes common to all messages. The my message class provides additional methods that set MIME specific attributes. The client program can also set non-standard attributes, custom headers as name value pairs. The methods for setting standard attributes set from, set recipient, set reply to, set sent date, set subject, etc. The part interface specify the following method that sets the custom headers. Is called a public void set header, string name, string value. To set recipients method, the set recipients method takes recipient's type as its first parameter, which is specified which recipient field to use. Currently message.recipient.to, message.recipient.cc and message.recipient.recipient-type.bcc are defined. Additional recipient types may be defined as necessary. The message class also provides two versions of set from method. Set from address DDR specify the sender explicitly from an address object parameter. Set from without parameters retrieve the sender's name from the local system. That's the other version. The code sample here sets attributes for my message just created. First is it instantiate address object. Address objects to be used as 2 and from addresses, then it calls set methods which equate those addresses to appropriate message attributes. Now we are considering using the transport class in transport protocol some mechanisms. Here then the session object uses a transport object to send a message. The class transport, an abstract class that models a message transport. Subclasses provide actual implementations. The code segment here sends a MIME message using a transport class implementing the SMTP protocol. The client creates 2 internet addresses client creates 2 internet address objects that specify the recipients and retrieve retrieves a transport object from the default session. That supports sending messages to the internet addresses. Then the session object uses the transport object to send the message. Here get the session. Create an empty MIME message and its part. Add headers and message parts as before. Create 2 destination addresses. Get the transport that can handle sending messages to internet addresses. This will probably map to a transport that supports SMTP. Add ourselves as connection event and transport event listeners. Connect method determines what host to use from the session properties. The send message to the addresses we specified here. Now we are considering reading the contents in message security. The code sample here shows one possible techniques with the message containing encrypted content. there will be times when an applet or application needs to retrieve the content of the message without displaying it. The code sample here shows one possible technique with the message containing encrypted content. The getContent method returns a multi-part encrypted object. There will be methods on this class to decrypt the content. The decryption could either determine which keys needed to be used and use default may be the current user's key, or explicitly pass which keys certificates to use. The message gotten from some folder. The use of use the default keys or search from the user. We should also be able to determine whether or not to interact with the user. Should then be able to use the multi-part methods to get any content blocks. As an example, we can consider class messaging exception. The base class for all exceptions thrown by the messaging classes. This is in the module jakarta.mail and package jakarta.mail.